Okay, so for this problem, she is bowling with her friends. She pays $3 to rent shoes and $4.50 for each game of bowling. So she only has to buy the shoes once, but she is paying for multiple games. So that is our variable x. I know she paid $3 to get in and $4.50 per game. Then what I want to do is I want to subtract 3 on both sides. Okay. Then to isolate my variable, I want to divide by $4.50 on both sides. And I get 4. So she played 4 games. Okay. Number 2 wants me to solve for x. Both sides of the equations have numbers outside the parentheses, so what I want to do is I want to go ahead and distribute in. I have 5 times x, which gives me 5x, 5 times 1, which gives me 5, 2 times 3x, which gives me 6x, 2 times 7, which gives me 14. Then what I want to do is I want to go ahead and get all of my variables on one side and then all of my numbers on the other. I'm going to start by subtracting 5x on both sides. I get 5 equals x plus 14. Then I want to isolate my x, so I'm going to subtract 14 on both sides. And I get negative 9 equals x. Okay. Number 3 is a mixture problem. It's asking me how many milligrams of a metal containing 45% nickel must be combined with 6 milligrams of pure nickel to form an alloy containing 78% nickel. So first thing I want to note is pure nickel is 100%. So I'm going to set up my table. I'm going to have my percent, my milligrams, and my concentration. I can spell concentration. Okay, so the first thing I know is I have 45%. I didn't mean to write that as a decimal. I don't know how many milligrams I have of it, so this is my variable. I have 100%, and I know that I'm going to use 6 milligrams of it. I want an end result of 78%. It's going to be the 2 milligrams together. Then for my concentration, I take the percent as a decimal and multiply it by the milligrams. So I'm going to have 0.45x. 100% as a decimal is 1 times 6. And 0.78 times x plus 6. So then what I want to go ahead and do is I want to set this up as an equation. I'm going to set this up to the side. So I'm going to have 0.45x, 1 times 6 is just 6, equals 0.78 times x plus 6. Then what I want to go ahead and do is I want to distribute on the right side. .78 times x is 0.78x. Then I need to do 0.78 times 6, which gets me 4.68. Then I want to go ahead and get all of my variables on the same side. So I'm going to subtract 0.45x on both sides. I'm left with 6 on the left. 0.78 minus 0.45 gets me 0.33x plus 4.68. Then I want to subtract the 4.68 on both sides. And I get 1.32 equals 0.33x. I want to divide both sides by 0.33 to get my x alone, which gives me 4. So 4 milligrams. Okay. Number 4 wants me to write in terms of I and then simplify as much as possible. I'm going to start by separating into the negative square root of 1 and the square root of 343. I know the square root of negative 1 is I. 343, I'm going to do a factor tree. I know it's divisible by 7 just because I work with this number a lot, so I recognized it. But I could divide by 343 until I get a number that works out nicely. So if I do divide by 7, I get 49. Then what I can do is, I know 49 is 7 and 7. So I have a pair of 7s that goes outside with the I, and I have this leftover 7 which stays on the inside. And that is my final answer here. Okay, number 5 wants me to simplify each expression. So what I want to do here first is I want to take out the negative 1 and rewrite it with it. Okay. Then what I can do is I can rewrite my square roots of negative 1 as I. So I have I square root of 3 times I square root of 32. What I want to do next is I'm going to multiply. I times I is I squared. And when I'm multiplying two numbers inside the radical, I can just, or when I'm multiplying two radicals, I multiply the number inside. So 3 times 32 is 96. I know I squared is negative 1. And then I want to go do my factor tree for 96. It's even, so I'm going to start off with 2. Then I have 48, 2 and 24, 2 and 12, 2 and 6, and 2 and 3. So I have a pair of 2's here and a pair of 2's here. Those are going to go outside, and I take 1 from each and multiply, so I have 2 squared. And then I have a leftover 2 and 3. Those stay inside, which gives me 6 because I multiply those together. I have negative 1. 2 squared is 4. Still times the square root of 6, which gives me negative 4 square root of 6. Okay. On B, I want to start by rewriting it as the square root of negative 1 times the square root of 90 over the square root of 5. What I can do is I can turn the square root of negative 1 into I. And since the 90 and the 5 are both inside a radical, I can rewrite it as one giant fraction in under one radical. So the square root of 90 divided by 5. Then I can simplify that fraction. So I have I square root of 18. And now I could do my factor tree for 18. So I have 2 and 9 and 3 and 3. 3 will come outside to join the I. 2 is a loser and it's left over on the inside because it doesn't have any friends. And I get 3I square root of 2. Okay. This one wants me to simplify. It wants me to write it as a complex number in standard form. Notice I have a minus right here, so what I want to do is I want to go ahead and distribute negative 1 to everything after it. So the pieces out front stay the same, 4 plus 3i. Then I have negative 1 times 5, which gives me negative 5. Negative 1 times negative 2i gives me positive 2i. Then I'm combining like terms, so I have a 4 and a negative 5, which gives me negative 1. I have a 3i and a positive 2i, which gives me positive 5i. Okay. For number 7, it wants me to multiply and then write it as a complex number in standard form. So no I squareds. Okay. So I'm going to do this. I have 4 times 5, which gives me 20. 4 times negative 3i, which gives me negative 12i. 2i times 5, which gives me 10i. 2i times negative 3i, which gives me negative 6i squared. I want to combine like terms in the middle. I have 20, negative 12 plus 10 gives me negative 2i. And then negative 6i squared turns into negative 1. Want to simplify again. I have 20 minus 2i. Negative 6 times negative 1 gives me positive 6. Then I want to go ahead and combine like terms. 20 plus 6 gives me 26, still minus the 2i. Remember also when we're in standard form, real part comes first, imaginary part goes second. For number 8, it wants me to divide and write it as a complex number in standard form. So remember when I'm dividing, I multiply by the complex conjugate. So I have negative 6 plus 2i over 5 plus 3i. My complex conjugate is the bottom number and changing the sign. So I'm going to multiply by 5 minus 3i. On the top, I have negative 6 times 5, which gives me negative 30. Negative 6 times negative 3i, which gives me positive 18i. Positive 2i times 5, which gives me 10i. Positive 2i times negative 3i, which gives me negative 6i squared. On the bottom, I have 5 times 5, which is 25. 5 times negative 3, which is negative 15i. Positive 3i times 5, which is positive 15i. Positive 3i times negative 3i is negative 9i squared. Then I want to simplify. So on the top, I have negative 30. 18 plus 10 is 28. Negative 6 times negative 1. Then on the bottom, I have 25. The 15i's are opposite signs, so they cancel out. Minus 9 times negative 1. Then I'm going to do the multiplication. So I have negative 30 plus 28i plus 6, because negative 6 times negative 1 makes it positive. On the bottom, I have 25. Negative 9 times negative 1 is positive 9. So I'm going to combine like terms. I have negative 30 plus 6, which is negative 24, plus 28i. On the bottom, I have 25 plus 9, which is 34. I'm going to split this into two fractions. I have minus 24 over 34 plus 28i over 34. Then I can simplify each of my fractions. Negative 24 and 34 are both divisible by 2. So I have negative 12 over 17. And then for the second part, I have 28 and 34, also both divisible by 2. 28 divided by 2 gives me 14. 34 divided by 2 gives me 17, and I still have my I. Okay, number 9 wants me to simplify this complex number as much as possible. So I want to rewrite the power as something with that's a multiple of 4. 16 is a multiple of 4, and then adding 1 gives me 17. So I can rewrite this as I to the 16th times I to the 1. I to the 16th is 1. I to the 1 is I. 1 times I is just I. Okay. Number 10 is telling me the length of a rectangle is 3 times its width. So I have my width, and the length is 3 times that. If the perimeter of the rectangle is 58 meters, what's the area of the rectangle? So this is also going to be W, and this is going to be 3W. I want to add up all the sides. I have 3W plus W. Notice there's 2 3W's and 2 W's. So I am going to have this in a parentheses times 2 equals 56. Okay. I'm going to divide both sides by 2. And 3W plus W is 4W. 56 divided by 2 is 28. Then I'm going to divide both sides by 4. And I get W is 7. My question was not what the width of the rectangle was, but the area. So if I know W is 7, then the length is going to be 3 times 7, which is 21. So to find the area, I have to take 7 times 21, which gives me 147. So my area is 147 meters squared. Okay. Number 11 wants me to solve. It's already factored, so from here I just have to use the zero product property. I'm going to do 4x minus 2 equals 0, and 9x plus 1 equals 0. Then I'm going to solve them as two separate equations. So on the first one, I add 2 to both sides. I have 4x equals 2. Divide both sides by 4, and I get x equals 1/2. It's one of my answers. Then I'm going to keep solving for the other equation. I'm going to subtract 1 on both sides. I have 9x equals negative 1. Divide both sides by 9, and I get x equals negative 1/9. Okay. This one wants me to solve. I have to factor. Since I only have x terms, I can factor out an x, and I also notice that both of my coefficients are divisible by 4. So I'm going to divide them both by 4x and write that out front. 4x squared divided by 4x is just x. 12x divided by 4x is 3. Now I have two factors multiplying to each other, and I can set them equal to 0 and solve those. So I have 4x equals 0, and x plus 3 equals 0. My first one, I divide both sides by 4. I get x equals 0. On the second one, I subtract 3 on both sides, and I get x equals negative 3. On number 13, I need to first factor this one. I'm looking for what multiplies to negative 36 and adds up to positive 5. This is going to be negative 4 and positive 9. Negative 4 times positive 9 gives me negative 36, and negative 4 plus 9 gives me 5. Once I have done that, I want to take each of my factors and set them equal to 0. On the first one, I add 4 to both sides. I get x equals 4. On the second, I subtract 9, and I get x equals negative 9. Okay. Number 14, what I want to do is I want to get it equal to 0 first, so I'm going to add 2 to both sides. I have 3x squared minus 7x plus 2 equals 0. This one, since I don't have a coefficient of 1, I'm going to solve by using the AC method. So my A is 3, my B is negative 7, and my C is 2. I'm going to do 3 times 2, which gives me 6. I'm looking for what multiplies to positive 6 and adds to negative 7. This is going to be negative 1 and negative 6. So what I'm going to do is I'm going to split my middle piece up. So I'm going to have 3x squared, and instead of writing negative 7, I'm going to rewrite it as negative 6 x minus 1x plus 2. Then from there, I'm going to take it and I'm going to set it into two groups. My first group I'm looking for what they have in common. They both can be divided by 3x. So I write that out front. Then I write what I get left over from dividing on the inside. 3x squared divided by 3x is x. Negative 6x divided by 3x is negative 2. Then I'm going to go ahead and do the same thing for the second set of parentheses. I just want to make it positive, so I'm going to divide by negative 1 on both sides. I end up with x minus 2 inside the parentheses. Then what I want to do is I divided by negative 1. I want to undo the distributive property, and so I am going to write 3x minus 1. I took the two outside pieces and put them together. Then times x minus 2 equals 0. I'm going to go solve those individually over here. I have 3x minus 1. X minus 2 equals 0. On the first one, I add 1 to both sides. I have 3x equals 1. Divide both sides by 3. X equals 1/3. Over here, I add 2 to both sides. I get x equals 2. Number 15 wants me to solve. Before I solve, I want to multiply out my right side so I can combine like terms and set it equal to 0. So I'm going to leave the left side alone for now. Then when I'm squaring this, I actually write it out twice. Okay. So I remember to FOIL. Otherwise, it gets kind of confusing and you might forget some of your middle terms. So I have x times x, which gives me x squared, x times negative 4, which gives me negative 4x, negative 4 times x, which is negative 4x. Negative 4 times negative 4 is positive 16. I'm going to go ahead and combine like terms on my right side so the left side stays the same again. Negative 4x minus 4x is negative 8x. Then to get all of these over to the other side, I'm going to change their signs. So I'm going to subtract x squared, I'm going to add 8x, and I'm going to subtract 16. I end up with x squared. Negative 19 plus 8x is negative 11x. 40 minus 16 is positive 24, equals 0. Now, I'm just looking for what multiplies to positive 24 and adds up to negative 11. This is going to be negative 3 and negative 8. Still equaling 0. Then I'm going to take each of my pieces and set them equal to 0. So I have x minus 3 equals 0, x minus 8 equals 0. I'm going to go ahead and solve them both. My first one, I add 3 to both sides. I get x equals 3. Second one, I add 8 to both sides. I get x equals 8. Okay. Number 16 is going to be solving by the square root method. I'm going to start off by taking the square root of both sides. I get x equals plus or minus the square root of 72. Remember, when I draw the square root symbol and it wasn't already given to me, I have to write plus and minus. Then what I'm going to do is I'm going to go ahead and do my factor tree for 72. It's even, so I can use 2. Then 72 divided by 2 is 36. 36 gives me 6 and 6. So then what I can do is I can rewrite this as x plus or minus 6, because that's the number I circled, square root of 2, because that's the leftover. This one wants me to find the value of x that makes this a perfect square. So what you do to find perfect squares, remember, is you take the b value and divide by 2, which gives me 3. And then to find the value that makes it a perfect square, I just take this 3 and I square it, which gives me 9. So if I had this, I could factor this, and it would give me x plus 3 times x plus 3. Number 18 wants me to use the quadratic formula to solve this. I'm going to rewrite this off to the side so we don't forget what it is. It's x equals negative b plus or minus the square root b squared minus 4ac over 2a. Okay. Then my a is 2, my b is 18, and my c is 39. I'm going to go ahead and plug those values in. So I get x equals negative 18 plus or minus 18 squared minus 4 times 2 times 39 over 2 times 2. Then I'm going to simplify the stuff inside the radical. 18 squared is not something I know off the top of my head. It's 324. And then I have minus 4, so negative 4 times 2 times 39, which gives me negative 312 over 2 times 2, which is 4. Want to keep simplifying the inside. 324 minus 312 is just 12 over 4. Then I want to factor tree my 12. I'll do that over here. That's 2 and 6, 2 and 3, which means I can take out a 2. So I'm going to rewrite this as negative 18 plus or minus 2 square root of 3, still over 4. Then from here, since 18, 2, and 4 are all even, I'm going to split it into 2 fractions so I can simplify. I'm going to have negative 18 over 4 plus or minus 2 square root of 3 over 4. Negative 18 over 4 is negative 9 halves. 2 square root of 3 over 4 simplifies to just 3 over square root of 3 over 2. Okay. Number 19 wants us to find the value of the discriminant and give the number of real solutions to the quadratic equation. When I'm finding the discriminant, that's just the b squared minus 4ac part. So my a is 5, my b is 3, and my c is 1. I'm going to plug that in. I have 3 squared, minus, not equals, minus 4 times my a value of 5 times my c value of 1. So I have 9 minus 4 times 5 is 20 times 1 is 20. 9 minus 20 is negative 11. So this is 2 imaginary solutions. I could tell that imaginary. Sorry, I cannot spell and talk at the same time. I knew it was imaginary because it was negative. If it was positive, it would be 2 real, and if it was the number 0, it would be 1 real solution.